Hello my dear friends, welcome to Electronic Circuit Lab. Today I am going to tell you how to make a priority power supply circuit using Schottky diode. This is our project number 2. You can also make it using some ICs, but these ICs are very costly and this is a relatively cheaper solution. But it is a reliable solution. There is no issue for reliability in this for this circuit. So first of all, question is why Schottky diode, not PN diode? Because Schottky diode has a low voltage drop in the forward bias condition. You all know that in PN diode there is a forward bias voltage of 0.7 volt. And if you know the power of power is a V into I, more is the voltage drop across the diode, there is a more is the power consumed by the diode, and more power consumed will create heating effect. Okay, and second is because Schottky diode has a fast switching relative to the PN diode, so that's why we are going with Schottky diode, not PN diode. Okay, so these are the reasons. Now this is the block diagram. There is a what our project is. We have two power supplies, the main power supply and the backup battery, and your system will use the one of them at a time, but you want main power supply have more priority. That is, when the both the power supply are present at that time, the output will connect it to the main supply, not with the backup supply. When the main supply is not absent, only in this condition the backup will go to the output. So this is our requirement. Now the requirement also that this switching the main to battery and battery to main should be fast enough, because if it is not fast, your system will be shut down. The fast switching is required to prevent system shutdown. And second one, the main supply should have greater priority. If both the supplies are present at that time, the output will connect it to the main supply, not with the battery supply. Okay, this is the requirement. So on the basis of these requirements, I have suggested this circuit. These are the diode 1, diode 2, diode 3. These all are Schottky diode. There are two paths. In one path, there is a one diode. In other path, there is a two diode, as is shown here. What will happen? The main supply, because if I consider the 0.4 volt of forward bias voltage, and I am going to consider this is a 5 volt, or the backup is something 3.3 volt. You can because one condition is there, the main supply should be relatively at least 0.4 volt more than the backup supply, or may at least 1 volt more than the backup supply. Okay, 1 to 0.4 volt. So but this condition can be overcompensated. You can add one more diode here, so these condition can be adjusted. Okay, this will all these setting adjustment you will get if you know the actual working of this circuit. So what is happening here? The main supply, if you consider for example a 5 volt is main, the 3.3 volt is the battery backup. So when the 5 volt and 3.3 are both available, both are present, the output should be main. Like if I consider this diode is conducting, so 0.4 volt will be dropped here, and here I will get 4.6 volt, and 4.6 volt is here. If I consider this diode is conducting, then here is 2.9 volt, and 2.9 is lesser than 4.6, so this diode is not conducting. It is not conducting. So this is open circuit. So it is open circuit, so the output will connect it to the main supply. When main supply is not there, this 4.6 is not there. So this 2.9 is greater than 0, then this supply will go to the output. Okay, this is the basic principle of this circuit. If your circuit is not switching, you can add one more Schottky diode in the series. By if this gap is less, you can add one more Schottky diode here. Okay, some suggested part number for the IN58202122. This is from Vishay Electronics. You can go for it. and this is the curve of forward voltage to the forward current. At 0.4 voltage 1 ampere current. If your circuit is drawing lesser current, this voltage drop will be 0.2 near 0.2 also. Okay, so this is the truth table. When the main supply is present, battery supply is present, output is the main. If main absent, the output is the battery. If main is present, battery is absent, then also output is the main. If both are absent, go and switch on the supply. There is no output. Now, there is another use of this Schottky diode, which is very frequent use. Frequently in every circuit, the Schottky diode is used in reverse voltage protection. Like if your system is operated by an unskilled worker and he or she don't know, or by mistakenly he or she connect the supply positive and negative reverse, like positive connected, like negative here and positive here of your source. So if this diode is not there, your system can damaged. So you need a reverse voltage protection or reverse supply protection. Like if someone by mistakenly connect a reverse voltage, your system will be protected by you just add a Schottky diode here. So if here positive and negative, if someone connected negative terminal here, so this diode will be in open condition, open circuit, and circuit will not completed. This is open diode, open circuit, and the circuit will not completed. So the yes, system will be there is no damage of your system. So you can use this diode, Schottky diode, in reverse voltage protection, but not PN diode, because the reason is the previous one, that there is a forward bias voltage drop in the PN diode is 0.7, and in this circuit Schottky diode is a 0.4 or lesser. And one of another reason is this is fast switching. You can fast switch